Haptics are becoming a part of our daily lives. Our digital devices now provide this additional modality for communicating information and affect. Yet, we cannot utilize them effectively. It is challenging to make engaging and expressive haptic sensations, to evaluate users' reactions to these sensations without running time-consuming user studies, or to personalize these sensations for our preferences and needs. Existing design tools allow precise control of low-level engineering parameters, such as frequency and waveform. While these controls are necessary for design, they hinder rapid adjustments by designers and personalization by end users. What if we could design and modify haptic sensations along perceptually salient dimensions? Which perceptual dimensions are effective for designers and end users? To answer these questions, we studied how people describe and make sense of haptic sensations. We focused on vibrations as the most mature and accessible type of haptics, and found that people describe vibrations in 4 different ways. According to their sensory attributes, for example, they may say, "This vibration is too strong," or their emotional connotations. One might say, "I want a lively vibration." People may use metaphors and say, "This feels like a heartbeat." And finally, sometimes people describe how they see themselves using a vibration. For example, one might say, "This is a good notification for when my battery is low." We call these haptic facets. They capture 4 different ways that people describe and make sense of vibrations. To utilize the facets, we designed a library of 120 vibration patterns and collected a rich dataset of descriptions for the vibrations according to all the facets. Initially, 3 haptic experts provided descriptive tags and ratings for all the vibrations in all the facets. Next, we validated these ratings and tags in a user study with lay users. This process resulted in a rich dataset of tags and ratings for each facet. We used these facets and their ratings and tags to design an interactive interface called VibeWiz for browsing and searching our vibration library. However, the list of tags and ratings in their primary form cannot support design, as there is no structure or hierarchy for the lists. So we asked, is there a semantic structure for these facets? To study the structure of the facets, we used an established mathematical model called multidimensional scaling, or MDS. MDS is extensively used in the literature to study the perceptual space of a set of items. Applying MDS to the facet properties led to a set of dimensions that structure the flat list of facet properties into a continuous space. For example, for the emotion facet, we found 3 dimensions of agitation, liveliness, and strangeness. These dimensions are more nuanced than the generic valence and arousal dimensions used in the previous studies. Similarly, we derived a number of dimensions for the other 3 facets. Next, we asked, how are these different facets interlinked in people's minds? Our analysis shows that the facet dimensions are highly correlated. For example, vibrations with high tempo are considered more lively than the ones with low tempo. We found that these correlations can be described by 4 concepts: urgency, liveliness, roughness, and novelty of the vibrations. Our results indicate that several facet dimensions are linked to the urgency of the vibrations. Also, the 3 emotion dimensions explain 3 out of the 4 facet concepts, highlighting the importance of emotions in people's perception of vibrations. We used these facet dimensions to develop sensory and emotion tuning controls for vibrations. Specifically, the emotion dimensions, such as agitation, liveliness, and strangeness, provided good candidate sliders for tuning vibrations, while the facet interlinkages helped us define the underlying mechanics of these sliders for tool development. Our results inform design, evaluation, and personalization of engaging haptic sensations.